Hi everyone, welcome to my new playlist, and in this playlist we are going to study about the concurrency, and it is going to be our video 1. So without wasting any time, let's get started and study. Concurrency means that in our system, the system should be capable of performing multiple tasks at the same time. This is a simple definition of concurrency on the basis of the system. But let's talk about it on the basis of our databases. So in databases, we can just simply say that our database should be capable of doing multiple transactions at the same time. Then we can say that our database is concurrent. So let's understand that is our system and databases are able to do these transactions at the same time or not. Let's understand it with an example that I mentioned it here. I mentioned one table. So I mentioned one row in it that there is a seat ID 123 and there is a status, and I mentioned the enums free, logged and booked. Current status of this, like currently it is free right now. Now ID is null because this particular seat is not allocated to anyone. So ID is null right now and the status is free. So now what happens? There are three users, user 1, user 2 and user 3 make a action on this particular row, and there is a code logic written there that if we found the status is free, the user 1 will get a seat or user 2 will get a seat, any one of them will get a seat. So ID is going from null is going to change to that particular user ID, and the status is going to change from free to locked. This is something that we want to do. Now what happened? We got a request from all the three users at the same time, T1. These three users will enter into our system. So first user will enter, second user will enter, and third user. They all three are entering at the same time, and they will make a read call to our row. They are making a read call, and all the three are going to make a read call and get a value 123, 123, and 123. That is our seat ID, and everything is pretty fine. There is no problem in reading. They didn't do anything wrong. Everything is pretty fine and seamless. Now, according to our code logic, what it is written, if the status is free, then what we are going to do? If our status is free, then we are going to mark our status equals to logged and ID equals to 1. So all the three users will reach to this line if status equals to free, free and free. All the three users reach there. Now user 1 will reach to this row, status equals to logged and ID equals to 1. Now user 1 will make a DB call. So it will change our status to logged and ID equals to 1. Then what will happen? Our user 2 will also reach to the system and change the status from like ID status is going to be logged and ID equals to 2. Then if user 3 is going to reach, then the ID is going to be 3. But if user 1 already logged the seat, why ID changed to 3? So it affected the whole transaction. So it should be something like that. If user 1 is getting the seat, then why these two are performing the action on the same row? So this is the whole problem of dirty read. They are reading the wrong data because the status is logged right now when they are performing the action, and they read the data of free. So let's talk about how we can resolve this particular problem. So for resolving this problem, so this is our solution 1. What we can do? The three requests are coming in parallel. All the three users, user 1, user 2 and user 3 are performing the same action at time t1. All the requests are coming in parallel. So I mentioned the solution 1, that is single thread. In Java we have to implement it. We can use synchronized keyword above the function. So what will happen? Whenever we enter into the function, synchronized keyword will make sure that only one request will go into the function, and all the two requests, user 2 and user 3, have to wait. Okay, so now what will happen? User 1 will enter into the system, user 1 will make the changes into database, user 1 will mark the status equals to logged, and change the ID equals to 1. Now when user 2 is going to enter into the system, then it will not be able to perform any action. Why it will not be able to perform any action? Because now user 2 will enter, it will not get the status equals to free. It will get status equals to logged. Hence this time we will not going to perform any action for user 2 and for the user 3. Getting a right system. Previously we were getting wrong data in our system. We are getting the corrupted data. Our transactions are getting affected. This time we are getting the right data. But is this going to solve all the problems, this solution one? So let's talk about a problem in this solution. Like if we have multiple servers, then what will happen? So if we get a request from user 1 and user 2 at the same time, request will go to the load balancer, and now the request will reach to two different servers. Same request will reach to two different servers, like user 1 request will reach to server 1 and user 2 request reach to server 2. Now our calls will go to our function. There is a synchronized keyword, but the thread is going to be logged on the server 1, and in the server 2 we are again going to log one thread. So eventually we saw in server 1 there is one thread, and in server 2 there is going to be one thread. So total number of threads are 2 right now. So again there can be a problem if there are multiple servers. So this single thread solution is going to work perfectly when we have a single server, but it is not going to work perfectly when we have multiple servers, or we can just simply say when we have a distributed system. So we have to solve this problem for distributed system as well. So for distributed system we are going to study in our next video. So thank you for watching me, and let's meet in our next video. Bye bye.